Okay guys, I'm going to go ahead and finish up your homework and then go into the next side of notes for this sort of supplemental review here. 919293 mathemedic. In a right triangle, the sine of 22.6 is 5 over 13. Find the cosine. So draw a picture to help solve. So hopefully by now you realize that a triple is a 5, 12, 13. And if you want the sine of that, and the sine is 5 over 13, opposite over hypotenuse, I'd be talking about this angle. So this angle would be 22.6. We know that the other angle would have to be 67.4. So the question is to find the cosine of 22.6. All right, so the cosine of 22.6 is 0.923. So what I hope you're realizing by now is that the ratio, so if I went from here and did 12 divided by 13, that answer would be the exact same. So the cosine of an angle is the trigonometric ratio, the ratio of the side lengths, the proportion of side lengths. No matter how big the side lengths are, they have to be, in order for those two lengths to make that 22.6 angle, there can only be a certain number of ratio of the side lengths. It's kind of cool. All right, in a right triangle, the tangent of A is 1.5. Okay, so if this is A, I know tangent to be 1.5, so that would be opposite. I'm going to change that to 3 over 2. Opposite over adjacent. So I could do 3 squared plus 2 squared to get 13. And this would be the square root of 13, which would be 3.6. All right, but which side is longer, the opposite or the adjacent side? Well, it's the opposite side. So we see that in the triangle. That's just sort of to visualize it once you need to explain. If you're using your words, since tangent A is greater than 1, 3/2 is 1.5, the numerator must be larger. And that is the opposite side. So I hope that makes sense. You're sort of parlaying it into some thinking. Is it possible to have a right triangle where the sine is 3/2? No. Okay. Because, all right, so let's just use the same triangle. If that's A and the sine is 3/2, that means that would be opposite over hypotenuse. Does it make sense? Because the hypotenuse must be the longest side. Alright, so since sine is opposite over hypotenuse, it is always less than 1. Sorry, I did not realize I was off the grid. So tangent is always greater than 1, and sine, and cosine for that matter, are always less than 1. Okay, so go ahead and turn the page to the next 9.2. I'm just going to keep going with this here. And on New Year's Eve 2010, Travis Pastrana broke a world record by jumping his rally car 269 feet in the harbor at Long Beach, California. The jump had to be perfectly engineered with the appropriate launch ramp and the landing ramp. So we're going to watch that in class. If I will send you the YouTube link if you watch it on your own. It's just 2 minutes. It's just kind of a cool thing that really happened where he jumped over that ramp. But the launch ramp was constructed with an angle of 32 degrees with the ground and a length of 113 feet. We want to find the height of the car from the ground when it launches. So these are some other examples of things that we have done these past couple of weeks. All right, so let's draw a picture of the launch ramp and label all the information. So he took off, and once you watch the video this might be a little bit more sense, but he took off. This is 32 degrees. It was a car. There's my best car, I think. But he over the water. All right, and then he landed. So we'll talk about the landing a little bit. But for now, this is his launching pad. And the length of that launch pad was 113 feet. So that's important. We've talked a lot about that, is how you label your right triangle. Okay, was 113. So we want to find the height of the car from the ground when it took off. So we're looking for this height, but when he took off, I mean, my picture is not bad, he's going this way, but this is the angle in question, like right there. Where did he take off? What was this height when he went over there? Okay, so the best one that we're going to use is going to be sine, because I'm looking for the opposite side and I know the hypotenuse. So sine would be the best to use. Why? Because I'm going to abbreviate because I am looking for opposite side and I know the hypotenuse. So opposite over hypotenuse is sine. Okay. Write an equation. I don't know why I squished that all there, but I did, sorry. Using the trig function, and then solve it to find the height. So we're just going to go ahead and solve it. So the sine of 32 is equal to the height of the ramp over 113. So I'm going to cross multiply to do, can you guys see this? Scoot, clean up shop here a little bit. 113 times the sine of 32 to get 59.88. Okay, so the height is 59.88, and I think that's it there, feet. The landing ramp was constructed on a barge on the water. So the engineers had a limited horizontal distance for the ramp. And if you see the video, it's wild because he lands and you're like, oh, why wasn't he going further? And then you see where it stops. You basically would have hit a wall. A lot of Navy planes, when they land on a barge in the water, they have a really, really, really short runway because the barge can only be so long. Okay. Now in this case, if I just pick up the same picture that I just drew. Now I'm just landing on this barge. But this was, they just had a really, really, really short, limited amount of that landing space. But airplanes that land on the ocean during, wartime, things like that, they have a really short runway to both take off and to land on. So this is kind of relevant. They needed a height of 98 feet. Okay, so this is 98 feet. Now keep in mind his car's coming and then he's going to land. Okay, and then he's got this landing strip. What's next? They needed a height of 98 feet with an angle of elevation of 36 formed with the ground. So we want to know the horizontal length of the landing ramp. Okay, so there's our 36 degrees. Okay, so how much of this landing space does he need to land? Okay, just for the sake of the picture, I'll say that's 36 over there. So this is our angle in question. And from that angle, I know the opposite side. And I'm looking for adjacent side. So I hope you see by now that that would be the tangent. Tangent. This is my symbol for because. We have the opposite and looking for adjacent. Again, I squished it in there. Write an equation using that trig function to find it. So go ahead and say that the tangent of 36 is equal to 98 over the length of that landing strip. The length of the landing strip times the tan of 36 is 98. So then to get the length by itself, we divide by tan. So in a couple of my last week videos, I was kind of jumping to that step, and that's why. Okay. So on my calculator, I'm going to make sure I do 98 divided by the tangent of 36, and that's 134.88 feet. Length of landing strip is equal to, I'll go ahead to 134.88 feet. Actually, it would be 0.89. I think last year I rounded this to the nearest tenth, but whatever, I'm in it now. Okay, the landing barge was 200 feet long. How many feet does this give Travis to stop the car before hitting the end of the barge? So this is my picture up here that I sort of tweaked. Here's my 36 degrees. So when he landed, whoosh, how much does he have? So if this whole thing is 200, and we just found this much of the landing strip to be 134.89, then I'm going to subtract 200 minus 134.89 to get 65.11 feet. Okay. Other side. Tape. All right, so just kind of a quick little summary. Again, this is to really bring trigonometry all the way home, and that we are going to rock it and have it for our special right triangles and also for our unit circle. So we are writing equations and solving for sides. So the first lesson was sort of to make sure you understand that trig is the ratio of side lengths. You want to make sure that you draw a picture. It really brings it home. You want to make sure you choose the proper trig function. And in that SOHCAHTOA family, you want to write the equation, and of course you want to solve it. Make sure you're in degree mode. Okay, so make sure you have the right setup and that the shortest side is opposite the shortest angle. So remember, longest side is opposite longest angle, which makes the hypotenuse, and vice versa. Okay. So I would like you to pause the video, honestly, for these 3 homework examples. Okay. Make sure you can do it. and then you can watch this video again. The reason I'm not stopping it is just to have one less link to post, selfishly. But pause the video right now, and then I will see you in a little bit. Okay, welcome back. So a right triangle has a short leg that is 7 units long and an angle measuring 36 degrees. So from that side, draw a picture of it and find the length of the hypotenuse. Okay, so if this is 36, 90 minus 36 is 54 degrees. Okay, so from this angle here, I'm going to use sine. All right, so the sine of 36 degrees is equal to 7 over that hypotenuse. So h times the sine of 36 is equal to 7. So height is 7 divided by the sine of 36. Oopsies. And that is 11.9. I'm kind of used to the 10th. I'm going to go 9.91. Okay. Couldn't use trig on that one, or I mean Pythagorean theorem, because you only need one side length. Find all the missing side lengths and angles. Okay. Another color here. So this is 51, this is 5. Now this is what a lot of you guys were struggling. So for your test, you want to make sure that you can find all of them. So finding the other angle is relatively easy because that's just 90 minus 51 to get 39. Put this over here so I don't have to keep moving it. Okay. So I'm going to use tangent of, I could do tangent of 39. Tangent of 39 is equal to side A over 5. So 5 times the tangent of 39 is equal to side A. 5 times the tangent of 39 to give me 4.048. So that's going to be 4.05. And this is 5. All right. So if you want to go ahead and use Pythagorean theorem, you can. That would be 4.05 squared plus 5 squared to get that answer. Second square root, second answer. Now, we want to get in the neighborhood of 6.43. All right, that was by Pythagorean theorem. What I do want you to recognize is that I use the rounded answer here, so it's going to be rounded in there. When you use trig, so let's say I'll use, we'll do sine of 51 is opposite over hypotenuse. So keep in mind I didn't know that yet. So the hypotenuse is equal to 5 divided by the sine of 51. 5 divided by the sine of 51 for 6.433. So it really wasn't an issue there, but you know, 100th doesn't really make a huge difference. But there you go. All right, on January 15th, 2009, U.S. Airways flight took off from LaGuardia Airport. 2 minutes later, it had traveled for 4 miles when it struck a flock of birds. The plane had taken off with an angle of elevation of 7.7. Draw a picture. So hopefully you're kind of getting better. 7.7 is kind of tiny. So there's my airplane taking off. And then that's where I fit all these birds. So there's 7.7. And it had traveled for 4 miles. The airplane had traveled. Well, that's the one that's on the diagonal. Okay? How high up in the sky were these birds? Okay? So the birds are hanging out. So you're looking for how high, but the plane had traveled 4 miles. But now the question is, at what height did it hit it? So this is the plane's distance of 4 miles. And if you dropped a perpendicular to the ground, that's what the question is. So I'm going to use the tangent of 7.7 is equal to h over 4. Okay. So 4 times the tangent of 7.7 is 0.54. Now, if you're thinking about this, oh, I lied. It's not tangent. I'm doing this with tangent a lot, so screw that up. Sorry. All right, that was a little bit off. So here's 7.7. I know I'm looking for the side opposite, and I know the hypotenuse. So that is, of course, everyone already corrected me, sine. So the sine of 7.7 is equal to opposite over hypotenuse. Okay. So 4 times the sine of 7.7 is 0.535. Right after the 5 is a 9, so I'm going to say it's about 0.536 miles in the sky. So that's what that vertical distance is saying. All right, I'm going to stop this video, call it part 2, and then we will do part 3. So do I want to see you soon, or should I go ahead and keep working through that? I really only want to upload one thing. So, what time is it? I think that's what I'm going to do. So sorry. So go ahead to 9.3. That's this answer here, just in case. Didn't think I answered that. I just kind of scooted it over there. Okay, I'm just going to keep you going so I can just post the one video. All right, so we have been using sine, cosine, and tangent ratios to find the missing side lengths of a right triangle. But what if we want to find the missing angle? So again, this was another piece that you guys were struggling with that I wanted to revisit before your test. So way back in geometry, well, for us it was in this class, math 2, and not even way back when, you learned about similar triangles. With your neighbor, brainstorm everything you remember about similar triangles. So hopefully you remember that angles are congruent and that sides are proportional. P-R-O-P-O-R-T-I-O-N-A-L. All right, so find each of the missing parts of the triangle. Show your work to explain, round to the nearest tenth. So I'm going to encourage you to pause the video again. If I'm teaching this, I will pause it, but if you're out there, I would encourage you to pause it on your own just to kind of learn this stuff. Okay, welcome back. What is the side of length A, or the length of side A rather? Show your work. So from this angle, opposite over hypotenuse, so the sine of 19.5 is equal to A over 9. So 9 times the sine of 19.5 is equal to side A. You can either use your Desmos calculator or your own calculator, and that is 3.00, so that's going to be 3.00 or 3. Okay, now we're looking for that angle. Okay, so because we know that the last triangle had the same sides, and therefore it's got to have congruent angles. So this theta value is 19.5 degrees. This is just kind of my setup here. All right. Now, what is the length of side W? Show your work. Take this down. All right, so I'm going to say that the sine of 19.5, same thing, is equal to W over 6. So 6 times the sine 19.5 is equal to W. Sine 19.5 times 6. If you put that in first, remember you've got to close the parentheses. Okay. So these triangles have the same side, so this would have to be 19.5 degrees. Okay. So write an equation showing this following. What's the sine ratio for theta? So this, the sine of theta, would be 5 over 15, which equal to 1/3. Are we seeing this pattern here? Even whether this is 3 versus 9, 2 versus 6, 5 versus 15, that theta would have to be 19.5 degrees. Since the ratio, this is our takeaway that I want you to understand, the ratio of the sides is the same as the triangles above. So the angles are congruent. So if sides are in the same ratio, the angles have to be congruent. So we've already done this. So some of you are like, why aren't we putting on their calculator? We will. Look, we will. If only there were an easier way. All right. So similar triangles allow us to figure out angles from side ratios. All right, so we're going to talk about these inverse trig functions. I'm struggling. This is F-U-N-C-T-I-O-N-S. Sorry. Inverse trig functions. And this says inverse. This is short for trigonometric functions. That's what all that says. And this finds angles. Finds missing angles. So we're talking about sine inverse, cosine inverse, tan inverse. So at our review the other day, I got a little bit concerned because some people were still like, when do we use that? So we use them to find angle measures from the sides. We're still going to set up the equation. And now we're going to solve for the missing angle. That word says missing. Okay, so for example, if I say, oh, I want to find if the sine of theta is 1/3, the thing that undoes a sine is a sine inverse. So that's how you would crisscross. So whatever I do to the left, I have to do to the right. That's where that comes from. So on your calculator, clear, second sine inverse of 1/3 should be 19.5. Yay! Okay, for each triangle, find the measure of the labeled angle. Okay, I'm going to ask you to pause one last time. Okay, welcome back. Find the measure of angle A. So angle A is over here. So I have the adjacent side 7 and the hypotenuse 6. So that means that the cosine of A is 7 over 8.6. What's going to undo that? The cosine inverse. So whatever I do to one side, I have to do to the other. On my calculator, second cosine of 7 divided by 8.6 is 35.5 degrees. I'll go ahead and do 5.2 degrees since I've stayed consistent. Okay, a right triangle has a short leg of 7 and the hypotenuse is 13. Draw a picture and find all the angle measures. Okay? So I'm going to say if it was the short leg of 7, if this is theta, I'll stick with sine. So the sine inverse of 7 over 13 is equal to theta. Because if I'm using sine of theta, that is equal to 7 over 13. So sine inverse of sine is what crisscross applesauce. That's where I got that. So second sine of 7 over 13 is 32.58. Now I want you to understand that even if you found this angle, then you would do the cosine inverse of 7 over 13 is equal to alpha. I'll say that that's alpha because it's going to be the complement of this. So if I found the other angle with trig, second cosine of 7 over 13, it will be 57.42. What's 90 minus 32.58? Oopsie. 90 minus 32.58 is 57.42. All right, lastly, 2 minutes later, struck the camera, narrowly wished that. From there, the plane landed safely in the Hudson River, 6 miles away. There were no fatalities and only mild injuries. Okay, so I want you to understand this plane. I'm not the best plane. We'll just make the body like this. Oh well, you get the idea. Okay, but it's going down to make an emergency landing. It narrowly missed the bridge, flying at a height of 1106. That's how high up it was. From there, it landed safely 6 miles away. So this is 6 miles. There were no fatalities, so draw a picture. What angle was it descending? This is the angle of depression. But it's equal to that angle of elevation that we talked about. Okay? So it's equal to that. So I'm going to use the I'm going to say the tangent of theta, this is going to be theta here, is equal to 1106 over 6. Tan inverse of the tangent is going to undo that. So that's where we get the tan inverse of those numbers. I'm running out of space, so I'm going to scoot over here. So the tan inverse of 1106 over 6 is equal to second tan 1106 divided by 6 is 89.68. Okay. Oh, okay. This is great, Grace. So this is in feet, but this is in miles. So I have to convert 6 miles. Okay, 1 mile is 5,000. What is it? 5280. 5,280 feet. So 6 times 5280 is 31,680. So that's what I'm going to convert this to. 6 miles is 31,680 feet. So when you get a crazy answer like that, like the answer I previously got was 89 degrees, you have to take a step back and say, oh, what did I do? So that's what I did. So this is going to be 1106 over 31,680, which is second tan 1106 divided by 31,680 to get our 2 degrees angle of depression. Okay, I will call it a day. That is the very end of our video. Have a great day and make sure you watch all the way through.